Right, let's get going. Hello, that's me. That's my contact details. I can bring this slide back up if anyone really wants to talk to me after we've seen me talk on this subject for a while. So, a little bit about me. I've been doing .NET development for about 15 years or so. Started working for a little local company in Telford, doing apps for local bus services. That was great fun. I once got to test a mapping system by going for a walk for an hour or two, and it was work, and it was great. Capgemini, I work for the contract to make sure that you guys all pay your taxes. Hey, I'm sorry. The Works, the big book place, worked for them for a bit. Protolabs, US company, terrific place to work over in Telford. They are very keen on modern technology, and just finished with Eurofins, and now I'm a self-employed contractor. I'm one of those guys your mum always warned you about. Yay! I work for me, so I've got no one else to blame. Program of events. I like films, so I have a program. I'm going with the slightly unevenly shaped who, what, where, when, why, how. The 6 W's. So, first off, who is functional programming? So, 3 people important to the history of functional programming. One of them's a developer. See if you can tell me which one. This gentleman here is Alonzo Church. He is responsible for quite a few things, but the bits that we're interested in down the bottom here. First off, the arrow. So if you've ever used an arrow function in C#, that's the gentleman. And this over here donates a parameter into a function, and it's the Greek letter lambda, hence the term lambda expression. It's thanks to him. This is Haskell Curry. Has something like 3 programming languages named after him. I will get on to what the heck this is all about in a bit. It's called currying, and that's the bit that I'm interested in. Now, could this be the guy? This is John McCarthy. He developed arguably the world's first functional programming language in the 1960s, Lisp, which I believe is still in use to this day. So what is functional programming not? It's not new. The point of the last few slides was to give some sort of idea of the age of this paradigm. It's been going as a programming language since the 60s, but in the maths world, it's been going since the late 1800s. Really flipping old. I have actually dug up copies of those old texts from the Victorian age on the internet. As a non-mathematician, they'll make your ears bleed trying to read them. I don't understand them, but there we go. This stuff is not new. It is not like the latest JavaScript framework or whatever, where it's here this year, gone the next. This has been around for a long time. It's not a language. It's a paradigm. What do I mean by a paradigm? If you want to take a metaphor of a musical instrument like a guitar, your programming language is the guitar itself or the flute or whatever. The paradigm is the type of music you play on it. Rock, jazz, country if you've got no soul, or whatever. It's the same here. Object-orientated is a paradigm, procedural is a paradigm, functional is a paradigm. They're styles of programming. We'll get into the specifics in a bit. It is not imperative or object-orientated. The folks that I've come across who've tended to be the most resistant to working functionally tend to be those who've been working in object-orientated for the last 20 years and have gotten very used to this as the way to work and don't want to try something different. Most of the folks that get more enthusiastic about it often are people entirely new to developing. I've been chatting to some of the summer interns when I was working in the US a couple of years ago, and they were saying this is what they're teaching at universities now. So it is not the solution to all of your problems, although I'd argue it is the solution to quite a few. Nor is it difficult, which hopefully I will demonstrate. It's different, but it's not difficult. So what is it? What actually does it consist of? It consists of a whole load of ideas. Immutability. That is that once a variable has been given a value, it may not change, not ever. You can create a new one based on the old one. You may not create a new. You may not change the state of that variable. Seems a bit restrictive, but it has its uses. Higher order functions. Funky buzz name for something that's not terribly complicated. This is just functions passed around as variables, either as a return from a function, as the parameter of a function. If you've used a func delegate, bang, higher order functions. You got it. Lambda expressions. There's another one. It tends to favor functions over statements. Now, what does that mean? A statement is something like an if, a where, a for, any of those guys. Those are statements. You don't tend to get them in functional languages. Generally speaking, if you're going really functional and you've got ifs and fors, you're doing it wrong. And you can actually develop entire applications in C# that way. Looks a bit strange, but you can do it. Recursion. We good on recursion? Yeah. Pattern recognition. Kind of come on to that in a bit. It's basically case statements with knobs on. We'll kind of get to it. Stateless. Kind of ties back to immutability. There is no state. This is one of the fundamental differences between object-oriented and functional. There's no state ever in functional, if you're doing it purely functional. In object-oriented world, you get an object, this contains the state, you update it periodically according to the business logic. You don't do that in a functional program. Monads. That's the one that tends to scare people when they try to understand it. And according to Douglas Crockford, the curse of the monad is that once you gain the ability to understand it, you lose the ability to explain it. So I shan't. And it is not difficult, which again I'm hoping I will demonstrate. Is there? Which one? Oh, this one. Thank you. Well done for spotting the deliberate mistake. You win. Referential transparency. Again, slightly scary word for something that's not terribly difficult to understand and really quite important, and wouldn't that be a terrible shame if I forgot to mention it? All it means is, the other name for it would be things like pure functions. This is a function may only rely on its parameters and nothing else. This tends to result in functions that are very stable, very easy to maintain, and very predictable, because they will always give the same result given the same input, no matter what. No matter the life of the system, the life of the universe, no matter what. They will always give the same answer to the same input. Where is it? This is the places you tend to see it. There's the pure functional languages, Haskell, Erlang, Elm, there are others, Lisp. I've honestly personally never used these guys. I've heard they're great. I've got colleagues and friends that have used them and love them. Fair play. I just haven't personally used them myself. JavaScript. JavaScript is the Wild West of the programming world. Anything goes in JavaScript. So of course it supports functional. It supports everything. But yeah, it totally does functional better than C#. And if you want a really wild ride, go and look at Ramda.js, one of my favorite things. C#, which is why we're here. So when is it? By this I mean, what is it good at? Where is it especially useful? Data processing. Converting data from one form to another. There we go. That is nice, easy, pure, predictable functions. That is what functional programming loves. Concurrent systems. Now why is that? That's because there is no state being tracked, and this strongly enables you to run as many processes in parallel as you like. You don't generally get race conditions or conflicts of interest between two things accessing the same state because there is no state. So if you are interested in concurrent programming, if you are interested in Azure Functions, this is the sort of stuff you want to think about, because this strongly again supports Azure, things like Azure Functions, Serverless. High criticality, because in general a functional program is more stable than any other paradigm. So if it's really important that this thing go up and stay up, functional will tend to support you a bit better. According to some of the guys that do pure functional languages, allegedly things like Erlang, once it compiles and goes up, you can't stop it. It will never come down again, allegedly. I've never used it. Take that as a thing I've been told. I've mentioned serverless already. When is it not? When is it? I wouldn't say it doesn't do these things, but this is where it's less comfortable. So these are the things where we have to make compromises. Functional programming likes predictability, likes purity, and there's nothing more impure than a human being or the file system. This is where everything is inherently unpredictable, and so things like UI, interactions with other services, with humans, any of that, that's where we have to find a way to compromise on our language purity. If again you want a metaphor, think of the two parts of a shadow. There's the dark umbra in the middle, and then a fuzzy grey ring around the outside. The penumbra, that's your UI and all the rest of it. This is where we've got to compromise. And what we want to do is keep the dark part in the middle as large and solid as possible, and then just compromise around the edges. Excuse me. Now, why is it? Why are we interested? What the heck do we even want from it? It's concise, and it is. You can take code that's this long and object-orientated, and it goes about that long in functional. It's really short compared to the equivalents. It's very readable, largely because of the brevity and the way that the operations are ordered. It's very testable, referencing back to things like referential integrity and purity for functions. And this is actually one of the big selling points for a lot of people, is it really supports things like BDD and the like. It enables concurrency, I mentioned that before, it's robust, it's fun, I like it. Okay, how is it? Let's get going. So this is not functional programming. This is good old-fashioned object-oriented code, the likes of which we've been looking at for years. What are our problems with it? Well, we're modifying state, we've got a list and we're adding to it. What actually does this function even do? It'll take you, some of the more experienced devs will probably be able to tell me in a few moments because you've seen this so many times. But take a junior dev and show them this, it might take them a while to think about it. As it happens, this is a CSV parser with a filter. And that's how it would look in functional. And if anyone at this point is saying, that looks an awful lot like Linq, that's because it's Linq. Linq is functional programming. Linq has been there since .NET 4, and it is literally how functional programming is done. When you call something like a select, you're feeding a function in as a parameter, and the select does not change the original data. It is creating new data based on the old, given this function that you pass in. That is precisely how it works. So in effect, to do functional programming, what we're trying to do is put the whole of C# into Linq. Sort of. But if you look at this, this is a lot shorter. It's really easy to read, and the order of the operations is logical. And that's another thing that aids making it easier to read. You write the operations that you want to be performed in the order that you would explain it to another human being. You could show that to your boss. Now, he or she might not be able to do it themselves, but they could probably understand it. Up till we get more complicated than that. You could even, if you want, go a bit further and create some funcs over there, converting the strings into whatever, and make it a bit more readable again. And you'd end up with something like this, where it pretty much reads like natural language. Great stuff. Easy to maintain. Ooh, that worked that time. It doesn't always work. Cool. So, this is a big block of old-style code, and I'm going to show us what we can do to make this an awful lot shorter and more readable. So this is a list of criteria for validating a NINO. Anyone know what them is? No? Yeah, National Insurance Number. Can you tell? I used to work for HMRC. So, yeah, I had to do a lot of mucking with these things. So this is a whole load of stuff. There's a lot of structure here. We've got a lot of checks, we've got return false earlies, and all sorts. How can we do this better, easier, and more functional? Like this. So, right at the top, we got a whole load of funcs. I've put them into separate bits with names just because making it readable. Don't have to. You could just literally put the arrows down the bottom there, and that would be fine. You could probably save yourself about 6 lines of code. Why not? And what this is an array of funcs, which is totally a thing. And having created my array of funcs, I am then calling .all. Hello. I'll put the slide. By the way, I'll be putting the slides up later. Feel free to take photos. I do not mind. But if you wish to save your camera, then I will put the slides up later if anyone wants. But dig in, by all means. Right. So what have I done? I have said .all. Now, what does .all do? .all evaluates each of the guys in here, and then runs it by each one of the items in the array, and then decides whether to return true or not. And what I am doing is passing this into each item of the array, one at a time, and because it's .all, if at any point one of those guys returns false, the whole thing terminates early. It doesn't bother to evaluate the rest of it. So all of that structure you saw on the last slide that was so long I actually had to sort of put a little animation in to show it to you, that's there, and that few lines of code. And all we have to do is pass functions around. It's easy. Nothing hard about that. And here's how you might take it a step further and create a totally generic one that you could just pop in a back of your code base somewhere, a validator, take a params func, and then you just literally make your object call .validate off it, and then pass it the list of functions that will validate this thing. And what you get back is a Boolean. Easy peasy. Saved yourself a whole load of code. And there is nothing more cathartic than deleting a whole heap of code. And you could even then break it into teeny little bits. You could break each of those big ones into each feature which is reusable. So I've got things like a hasLengthOf function, and are they all numeric? I've got a regex. And each one of these is building one on the other like Lego bricks. I've got some that are being used all the time, some that are used a bit, but the whole idea is that we're taking the reuse of code up to its logical maximum extreme. We're taking lines of code and making them reusable. Now, that seems like an awful lot of effort, but think about this. If you reuse that function again on a new function that you're building in production, you know the old one worked because it's been in production already, so you are reducing the overall risk to the project by using bits and pieces that you know work. And you could even find an efficiency saving for one of these guys, and if you're referencing it all over the place because it's a teeny little micro bit of useful code, the whole system benefits in one go. If you wanted to stick one of these out and start playing with, is it that high performance stuff with spans and the like? And then you end up with something like this. So as I've said, it's the same thing again, but now rather than having the little funcs stored as local variables, it's still readable, but I've just extended out the sort of things that you get out of Linq and given myself a whole load of new selectors and then called new validators off it. Easy again. And I could reuse most of those chunks a million times over on all sorts of other bits and pieces. I could probably write myself the one DLL that the project, the whole company could share, as long as you don't put any business logic in it. You're probably asking for it if you start doing that. So let's move on to some other topic. Now, I've talked about moving functions around. Now, this is the good old bank account scenario. We've probably all run into this at some point. We got ourselves a standard bank account with a balance and an interest rate. Inheriting off that, we've got a super duper bank account with a bonus interest rate. And then also we've got the dodgy bank account with a brown paper bag of money. At this point, I usually pick on a politician who's making waves in the news, but frankly, these days, take your pick. I give up. So this is how you would actually do it as of, I think, C#7. And bang, this is a switch statement. I don't know how many people have used these. I'm actually surprised how few, but you can now switch on an object. This is pattern recognition. This is what it is. Now, the pattern recognition functionality in a real functional language is a lot more sophisticated than this, and I think as of C#8 and onwards, it's going to be even more powerful. I have seen demos of this sort of JSON-like syntax that they use to do selecting. It's very cool, but I don't think it's there ready necessarily for production yet. But BA here is a bank account object. It's not a string or an enum, it's an object. And in each of my cases, I am selecting based on which object type on the inheritance tree I think it is. So if it's a dodgy bank account, this case will hit, and then it will automatically wrap that into this local variable, which inside this case statement, I can reliably believe is genuinely a dodgy bank account because the case hit and the wrapping is done for me. So that is one heck of a lot of logic now taken care of. We don't have to worry about checking against type and wrapping with safe wrap and checking against null. All done for you now. I think also as of C#8, this is a function as well rather than being a statement. So we're getting there. I had a chat with the head developer of C# a couple of years back when I was at NDC Oslo, Magnuson, and he said, "What are you doing in my room?" And then once I had been arrested and was safely constrained, they said that the whole point is that C# is going to become a hybrid language. Going forward, each release of C# is going to have more functional content than the one before it. And in fact, the F# guys work, the F# being the .NET pure functional language, or ish, those guys work, and the things that they need is feeding the development of C# and vice versa, so that the two are mutually benefiting. So the whole point is going to be that C# will support functional and more functional with each year that goes by. So, hence stuff like this. And this is an area of active development within the C# team. But it goes further than that. We don't just have wrapping based on type. We can also do a when, and we can when against the properties of the object. So this here is saying, given that this is a standard bank account, wrap it to this local variable. When the balance is less than 10,000, then do this, otherwise the other thing. Now, imagine how much code I'd have to write to do that longhand safely and have all the equivalent functionality. It would take pages. But this does it in a tiny little block like this. Nice and easy to read, easy to maintain. And here's how we can do some other interesting things along a similar sort of vein. This is taking pattern recognition sort of step forward with a little bit of functional messing. So here we go again. This is an array of funcs in tuples. Are we good with tuples? Yeah, cool. You'd be surprised. Now, here we've got a pair of functions in each row. The first one is a func that turns a decimal to a bool, and the second one turns a decimal to a decimal. So on this side, effectively, this is saying, does this rule apply? And each one of these returns a Boolean that says, yeah, that rule applies now, or it doesn't. This side is the transformation that should occur to the base variable, given that this rule applies. And then I just do it in this block of code right here. Conditions over there, lovely. It's a dot first. So again, Linq has done most of the heavy lifting for us. First, we'll just go through each of these in turn until one of them returns true. So first, where X condition giving the original salary in, that is the left-hand side. So the first one, where one of these takes this salary and returns true, that one will be returned in its entirety. And then after that, given that we've now got one of these tuples, we can just call the second function and pass salary in again. It's taken me a long time to explain that, and it'd probably take me even longer to write it out any other way, but here we go, we've done it in a few lines of code. So that is an entire business logic for a gigantic, complicated function, technically in one line of code. Although, yeah, it's a really long line of code. You want a bit of white space in it, but you get the idea. And that's the essence of the sort of thing that pattern recognition does. So here's another little bit of functional glue that you can use. This is called an alt. This guy, I'm kind of faked some stuff up here for the purposes of the demo, but I'm imagining a scenario where I've got multiple sources of data, and we've got one that's the most important, and if that fails, then we've got a second, and then you could extend this out as far as you like. Now, maybe one's a live database and one is a offline backup, maybe one's an XML file, I don't really care, but you get the idea. And I want to be able to put one bit of code in here that tells me in one go which are the data sources I'm going to use, and here is the order of preference, just go do the thing. I don't need to worry about repeated pattern where I'm checking against return types and all that sort of thing. And that's how I do it. So, this is an alt. That's again an extension method, so how do I do that? Looks kind of like this. So, this is my alt. It's a T input to T output, so that attaches to anything. And I'm taking my input this, which is the initial input. In my imaginary case, it was a string. Could be an object, could be whatever you like. And then a function is a function for the first one, function for the second one. And I've created another extension method called ifDefaultDo. So that means give me two functions, I'll check the first one. And if it does, this is a slightly scary looking null check for a generic, because when you do a generic, you can't do a null check because integer defaults to 0, Boolean defaults to false, you know the song. And if this thing comes back as false running the first one, run the else function, otherwise return the input from the first one. And then I use this here to check the first one, call this, and only run this thing if something's returned out. Easy peasy. It is. Yeah, I should say I didn't invent any of these terms. You will find these referenced all over the place. Some of them have multiple names, and I'll kind of if I know them, I'll try and call them out. I believe the technical term for this sort of structure is a functor, I think. Quick caveat, I am not a mathematician. I am an engineer. So I'm less interested in the maths behind it as I am what the heck I could do with it, because I want to build things. So I think I've tried to make my functionality, my terminology good, but I will try and call out, because I know there's a couple of structures I'm coming up where they do have multiple names, and there doesn't really seem to be a standard. Fork is another one. I could make an obscene joke, but I won't, because we're on camera. So, what is my fork? This is surprisingly useful. So imagine this, you've got one input, and then you want to run multiple operations on that same input in parallel, and then each one is going to return a value, and then they will all coalesce into a single result at the end. And you can extend this out in all sorts of interesting ways. I have written versions of this with like multi-stages and stuff like this, but I'm going a little simple at the moment, just to give you an idea of the sort of thing. This one is inspired by the advent of code. Anyone do the advent of code at December? Yeah, it's cool. No? Oh, it's well cool. 25 days of really hard programming challenges. And I'm the sort of nerd that really enjoys that sort of thing. So, this is a slightly simplified version of the actual puzzle. But we got a string up here, and what we want to do is have one process that's going to tell me how many A's, one process how many B's, one how many C's, and then we're going to return them into a sum. It's ridiculously easy, and honestly, I wouldn't bother excepting for example, but imagine any sort of complicated scenario where you might want to do something similar. It doesn't take much imagination. So these are my prongs. These are the parallel processes. You could even introduce a bit of, what is that? There's an asynchronous version of Linq that you can use, it Linq or something like that. Yeah, you could even throw something like that and it would be genuinely asynchronous. You could do that. And then here, this is the bit that ties it all together. This is my glue function. So this takes an enumerable of all the answers and then tells it what to do with the enumerable to turn it into one. As it happens, it's just sum. That could be a multiply, that could be all manner of interesting things. And what does it look like? Yay, kind of like this. So, first off, I've used something called a map. Map is terribly useful, and until you've started using it, you don't realize what you've been missing, because these things are awesome. Map is like a select, except it operates on the entire object at once. So instead of being operating on each item in an array, it would operate on the whole array as one object. Or you could, because I've used T in both cases for the input and the output, you could operate on objects. You can operate on anything, and all you have to do is a Linq style arrow function to convert it into the next thing, so you can turn practically anything into a nice Linq style chain of operations. It's lovely. And now I use this in my fork. So how do I use it? Well, I've got T input this, which is everything. I got a func of the enumerable of the output into just a single output. I've just got like int to int just to keep things simple. This is where you can make it complicated if you want. But this is my join func. So this thing is the join func and then a params, which is my array of funcs that turn the input into the output. And then you just do a good old select. The select operates on the array of funcs. And then I use my map and the only reason I'm using the map there is it keeps it really nice and concise. And that just says feed the join function into the resulting array. Magic happens. Now it looks a little clunky and awful, but the fact is generally you need to write things like this the once, and then you can just use it, because it looks lovely when you actually use it. You don't need to worry about the dirty machinery under the surface. So, moving on to another topic, currying. I said I would come to this. So, in an old-fashioned normal function, we've got an add here, which is int a plus int b. It looks like this. It's an arrow in a plus b. Let's say we've got a hypothetical curried add. If I gave this a 10 and 20 in the old style one, that gives me a 30. What would I get back if I had a curried add with 2 parameters and I only gave it 1 parameter? Anyone care to answer? It is, yeah. It's a function. Rule of thumb, by the way, with functional programming. If there is a question, the answer is functions. It's a thing. It always works. So, and the answer to that, more functions. So, yes. In a curried function, you give it the first parameter, you get back a function where the first parameter is filled in now, and it just needs the second one to actually collapse into a value. So if I fed a 10 into this, what I get back is an add 10 function that will add 10 to anything I pass into it. Now that does have its uses, as I'll kind of have some examples later. Now, can you actually do this in C#? No, not really. You can kind of do elements of it. You can't do proper currying the way it's done in a pure language where like flipping everything is curried, or like Lambda.js, like I said, one of my favorite things. But there we go, that's what you would get. So this is the sort of thing I might sort of bake up to kind of do my currying. These are arrow functions that return other arrow functions. So I've got two arrows. Effectively, you call the first one here with the x, and what it's doing is giving you back that. The y goes to x plus y, but this time now the text has been filled in because you've already called it. So you can put together a long string of parameters and you can fill them in piece at a time, or you could just reuse whatever's going on here and have a whole load of iterations of it in different forms. So here's an example of the sort of thing I might be able to do. This, incidentally, if anyone knows what this list of data is, you're my mate. This is the list of the first series episodes of Doctor Who from 1963, because Doctor Who is the best TV series in the entire world. It is, officially, if you put them in that order. So I have got a func here, which is doing a whole load of stuff. This is actually a func that returns a func. It returns it has four parameters, an A, B, C, and a D. My A is, what do I split the lines on? So in my case, it's a new line. Then the B is splitting again. So that is, what do I split the fields on? So in here, it's a comma. The C is, which field out of this slot do I want? 0, 1, or 2? And then the D is actually the input string that I'd be putting in the first place. So I want to apply them a bit by bit at a time. And you can do it with an apply. Now, apply is one name I've seen of given for this sort of thing. Partial application, I think, is the technical term for this. This is like taking a big block of parameters and just saying, I'm going to just do these two. It's not strictly the same as currying, but it's the same rough principle. And here I'm saying, here are the first two. So I'm saying, apply onto the original function. I'm giving you the new line and the comma. So that means that this now is a function that, given an input string and tell me which field you want, it'll just do the rest for you. So you could reuse this about 5 times in the same calling function, because you may have multiple CSV styles to parse, and that will accommodate it without you having to write a separate one for each type of CSV. Maybe this one is separated with pipes, maybe this one is a different kind of new line. There's all sorts of options, and this will accommodate all of that without needing to write a different function. That's the beauty of partial application. That's what an apply looks like. One of the ugliest bits of code I've ever seen, I'm going to be honest. Again, it's kind of like the sort of thing you would shove in a box and not worry about, because the beauty of it is how you use it rather than what it looks like, and what it looks like is really ugly. But what it's doing is returning a new func based on the old one. So you're giving it a func which has got this many parameters, it's giving you back one with this many, but it's the same principle as my add with multiple arrows. And because the way this works, you'd have to write one of these for every combination of how many inputs going in versus how many going out. You'd have to write a whole load of these depending on how many you want. So, you're really interested. Opinions may vary, but I quite like this in principle. So we've gone through the sort of most of the standard functional flow, and this is what generally you'll get out of a functional function. We start with a single thing. We might do something like split it into an array, because generally speaking, these things work best if you split to an array at the first opportunity you get, because a better metaphor for how we're working is more like TSQL than like old-style coding. So you want to split out to an array and start making list operations, one after the other, like where, select. So your where is filtering, your select are converting, but then the final bit is aggregate. Aggregate being take your many things, convert it to one. And that sort of thing's not terribly hard to do in C#. This is, again, the sort of thing code that we see all over the place for aggregating a string. We've got a string builder, because if you're not using a string builder and you're aggregating a string, you are doing it very wrong indeed. And we've got to check against the final line, whether it's the final one or not, hold back the comma, that sort of thing. Or you could just do it like that. Good old string.join, which has been around since like .NET 2, something like that. And it's not all that hard to use, but I am still astonished by how many people aren't doing that. And you've got all sorts of other options, like you've got your sum, average, there's loads of them. But what about an object? What about doing a slightly more complex aggregation on an object where you have to put a little bit more interesting code in there to be able to decide how to aggregate step by step? This again is some Doctor Who data, because Doctor Who's cool. And we've got story data, the code of the episode, its title, my rating for it, the number of episodes, and the number of missing episodes, and that's because there are 97 missing episodes of Doctor Who. It's very sad. And I want to do things like how many episodes are there? That's dead easy. That's just a sum. Been able to do that for ages. We could do averages. Been able to do that for ages. But what if I want to do a slightly more complicated operation? Like get myself a tuple, which contains how many missing episodes and how many actual episodes exist. You do something like this, which has been around for a long time, but again, I don't see many people using this, and it is really powerful. This is Aggregate. This is just Linq again, nothing I've made up. But this is the grown-up version of things like string join, of things like sum or average. This is where you're rolling the whole thing yourself. And what does it take? Well, first you give it a seed value. So that is, what do we do at the beginning? What is the starting value? And then after that, you give it a function as an arrow, and that takes two parameters. The accumulator, which is what we got so far, what's the running total of everything, and the current, which is like your X or whatever in a normal select. And then inside that, you say, given the running total and the current, here's how you transform that into the new total. And then it runs this on every item in the array, one after the other, and you get back whatever complex logic you want to turn the array into a single object. Nice and easy to read. There we go. Problem solved. So, how are we doing for time? Fair enough. Oh, there you are. How are we doing for time?
Well, he's here, so you can need a break now. Or...
Okay, how much time do you need on yours? Sorry? Okay, how long do you want me to carry on for? Okay, I'll try and whip through this very quickly. I won't do the whole thing here because I'll miss some slides off at the end. I can talk about that afterwards. I'll just try and blast this through because this is a really nice couple of slides. Apologies. Okay, Fahrenheit to Celsius. This is something that I had to deal with when I was working for a US company all the time. Converting Fahrenheit into Celsius, because being British, I would talk about the weather, and they would say things like it's like 100 degrees outside, and I would think, whoa, are you not dead? Oh, wait. Okay, that's all right. So what is the formula for converting from Fahrenheit to Celsius? Take a number, deduct 32, multiply by 5, divide by 9. Of course it is. Obvious, isn't it? I don't know. And then I'm also rounding and returning it in a nice string with the degree centigrade on the end to make it look friendly. So that is a whole load of functions, of operations, one after the other, each of which requires the input from the previous to do a thing. So how can we do this in a slightly more robust way? This guy is called an identity. This is the term. I've seen others, but identity seems to be the most common. So think of it as thing in a box. We've got a thing in a box. That's all it is. You'll see. Makes sense in a moment. So it's an identity of T. So that means my thing could be anything, any object. And all I've got in it is value. So that is my thing in its box. So far, so good. So far, so useless. Bear with me. A couple of little bits of syntactic sugar just to make it nice and easy. Implicit operators, we good with those? Yeah, it's just a bit of syntactic sugar because I can't be bothered with all that dot valuing. I just want to go this equals this. Too lazy. Right, couple of other little extension methods. ToIdentity, this attaches to everything and just says whatever you are, if you call ToIdentity off it, you get back that thing in a box. And bind. Now this is the same as our map. This is the really important bit. Our bind is the same as a map I've showed you before. It is, here is my thing in its box, This attaches only to identity of whatever it is. So you'll only see binds popping up of identities now. And then the bind says, give me a function that will turn the old one into the new one. So then we can do big long chains like this. And this, incidentally, is another way I would use my curried adds and subtracts and the like. These are all actually functions. That's by giving this thing a 32, it becomes a subtract 32 function. So it's a nice little bit of syntactic sugar again. And all this is doing is taking my input. Now each one, I'm converting it to an identity. So now I can call my nice new extension methods. And then I'm calling bind. And then each bind is saying, give me a function. I'll do it. And I'll pass out the result. And because it comes back, bind returns a new identity containing the new value. So you can call bind again. So each one of these is a step which takes a function, takes the old one, runs the function, passes it on to the new one, and you can write it in a nice chain. This is a monad. This is what they are. So if anyone ever says they're hard to explain, I don't agree at all, because that is what they are. That's all that they are. Now you can go an awful lot more complicated on the logic that happens inside the bind, and that's where we get our interesting fun bits. But in essence, this is all the monad is. How are we doing? I can stop at this point if you'd like. I've got a couple of variations on monad, but then that's it. Okie dokie. I'll just try and blast through these. Again, source code, I will make it available. I will be there for questions if you have any. So this is a slightly more advanced monad. This is called a maybe. I've heard this one called a few things. I've heard it called an option and a few other bits and bobs. But it's in essence roughly the same thing, except with a crucial difference. And the crucial difference is first off, it's got two forms. So the original maybe now is an abstract class. You cannot instantiate it. You can only instantiate one of the inheriting classes. Now here I've called them just and nothing. I have heard these called lots of things too. I've heard just called something, something and nothing, which actually I quite like. I've heard it called all sorts of stuff. But the principle is the just is the same as the identity that you've seen before. Thing in a box. And this is where it's fine. We've got a value. Nothing is nothing. And I inherit out, I have overridden value and turned it into default t. So this is nothing. So you've got one principle, which is the maybe, and then underneath that you've got two forms of it, a something and a nothing. So far so good. Then we've got a slightly more complicated bind. So this time we're saying we'll use our switches like we showed before. This is our switches based on type, and the switches on type are saying if it's a just, this is the input coming in from the previous function. So if it's a just, that means there is a value in it. And this is the slightly scary comparison against null. But basically, if it's come in, there was a value in it. The value was not the default value of whatever the heck this thing is, null generally. Then try to run it with a try catch. And then run the function, the converter function, and then return it as a maybe. Otherwise, in all other circumstances, either because it got caught by the try catch, or because it defaulted because it wasn't a just containing a non-null value, then return a nothing. So if you want to try and think of this metaphorically, the best way I've ever heard of was from Scott Vlashin's website, F# for Fun and Profit, very good website, a lot of good content on it. And he said, imagine it like a train track. So our whole bind tree of this monad operation is like a train track, and every bind is like a set of points along the track. The top track is it worked, it worked, it worked, it worked, and then we arrive at the happy station at the end. If at any point any of these guys didn't work, we switch tracks, and now we're on the nothing track. And because the nothing defaults over here, and all it does is return a new nothing, it does not execute the function. So it means that instead of function, we can put one definition with all the functions in a line, but the moment that one of them fails, we switch to the nothing track and just glide into the station without performing a single additional piece of effort. So again, imagine trying to write that longhand with our checks against null and whatever, and all those try catches to make this thing work, when this monad structure encapsulates all of that for free, and you never need to write any of all that longhand stuff again. So I'll just briefly show this. This is an either, because one of the common questions I get asked is How about error checking? Totally good question. And this is the same principle again, but you've got your left and your right. Your right is your happy path of justice. Your left is your left-hand path of darkness, where it failed. And you can actually have different stuff in them. So once again, my right is just basically another identity, but my left, it contains the last good value and the exception that was thrown. So then when you receive back the either, when you're handling it, you could do another switch. And then you could say, okay, switch against it being a right, in which case do the good thing, or else it's a left, in which case it was an error. Let's report the error and the last known good value. And if you've been writing pure functions, you know the input. The same input should always give the same result. So you should be able to completely recreate the error without any effort, fix it, and then throw it back into production. Easy peasy. And that's just the either. I'm not going to skip. I haven't used this personally, but there are NuGet packages out that implement a lot of these structures. LanguageX is the one I tend to hear around. Haven't used it personally because, frankly, I like to bake my own. And that's what my temperature conversions would look like. Roughly the same, except they match with like a pair of functions for the left and for the right. Further reading. Last slide now, then I'll rest. Functional Programming in C# by Enrico Buonanno, that's published by Manning. That is one of the best programming books I've read in years. I strongly recommend reading it. There is also a functional C# published by Pact by, forgive me if I don't pronounce this right, but I think it's Visnu Angoru. And that's pretty good, but the Enrico Buonanno, that is really, really worth your time to read. There's a YouTube video, Functional C# by Kathleen Dallard. I saw her give that talk live at NDC Oslo. It was a very good talk, and she covers a lot of the sort of ideas I haven't talked about, like, say, having a single global try-catch and stuff like that, and then just passing actions and funcs into it to do your stuff. A couple of Pluralsight videos, and if you want to go further, there's F# Fun and Profit, Scott Blashin. It's not just for F# guys. There are a lot of sort of like theory articles on there that are worth reading. And then finally, if you want to go hardcore, like you could always pick up something like Learn You a Haskell for Great Good and learn a Haskell. I haven't used Haskell myself, but I know friends that swear by it. So take that as it comes. That's it. Any questions? Stunned silence. No? Or are we all craving pizza? No, thank you.